Hey, hello guys, I'm coming back with this design that I uploaded the other day on my YouTube channel, Vargas Mongo 34, 35, 34, 35, Spanglish. Yes, it is Spanglish. Alright, I was checking on the IPS driver board and I was able to make completed yesterday. So today I will decide to check for mistakes or errors or basically debugging the IPS driver board for the audio high power audio amplifier. This is design is for more intended for high fidelity audio amplifier. I was trying to simulate it with more pairs, but I don't think I need to do that because I have other designs that are high power. They are high power amplifiers, so I don't think it's needed for me to modify this design just to get more power. I don't think it's needed because the only thing I can do probably just add one more pair, so just to get a little bit more, kick, just to get more kick. So right now, what I did, I just add one more pair. As you can see, this design is just for two pairs of power transistors. I do have, what the hell is this? I was making a joke, I forgot to delete that. That's a fish on the plate. Alright, that's for a friend. Alright, so as you can see, this is the original schematic. As you can see, I only have did I say half? We only have uh, two pairs of power transistor. You can see it has Q24, Q26. Those are the NPN power transistor for the output. What the hell happened here? I gotta move this up there. Sorry about that. What the hell happened? Sorry about that, guys. I move all this all over. Okay, sorry about that. There you go, 68. I don't know what happened. This is weird. Alright, there you go. So this is the original schematic. As you can see, it works with the 55 volt DC and has only two pairs. So what I mean two pairs, it means that it only have two NPN and two PNP. So that's why I say two pairs of power transistor. And the bottom one, Q25 and Q27, are the other two power transistor, the output. So on this PCB, this one is the one that I was using for the MOSFET amplifier that I designed the other day. But I can actually I just modify to feed those NPN power transistors. Right now I can feed the collector. The middle one is actually the collector. So right now if I hide the full screen, you will see that it will feed the voltage to the collector of those power transistors, NPN area and the PNP area. You can see I already edit those files, so I can feed with voltage the collector of those power transistor. Okay, Toshiba, you can use or any type of power transistor that you would like. Anyway, many people like to use Toshiba. I don't know why, because they are better transistor than Toshiba. I don't know why. Toshiba is I don't know why everybody love Toshiba that much, because you can use other type of, you can use MJL 3281. You can use other components instead of Toshiba. Anyway, I guess Toshiba is the brand that is more available in some other areas of the Europe and stuff like that. So anyway, you use whatever you like to use. So in my case, since I'm in Puerto Rico, I like to purchase this one here is kind of expensive, so I use the other one. I use the let me show you right now. So it's similar to this one. Okay, 32. So it's this one here. I use this one here, MJL 3281G. Sorry, AG. So this is a pretty good transistor. As you can see, bipolar power, NPN, 15 amps, 260 volts. So it will stand 260 volts. I do have those around my house. So right now, I'm in my room. So right now, okay. So this design is, I think, it's more intended for high fidelity audio. So I think it does not make sense to change this circuit just to get more power. But at least I can just make this IPS driver board, so I can I can feed the output power board. So okay, let me copy this so just in case for reference. So I'm going to do this is I'm going to eliminate these extra 3 pairs. I don't think it's needed to have more power, so I had to edit this PCB just for 3 pairs of power transistor. I think I need to space them out a little bit because they are way too close to each other. That's not good for thermal. So I might be able to accommodate the Sanken I think it's MT200, so that should be a good idea. So what I'm gonna do is I'm going to delete this. I don't think it's needed to have so many pairs, because it doesn't not matter if you add more pairs. That will not give you more power. That will depend on the IPS driver. So that's really important to remember that, because I do have circuits that can get delivered more than 500 watts. So one example I just want to show you right now, right quick. So I will complete this circuit here, and then I will share if you want to try it out as a prototype. I will say prototype because when you build something new, a new layout, you just make a prototype. I do have better designs here that can deliver a lot of power. This is the Honey Badger that I was able to simulate, and this one only have just 3 pairs, and this monster can deliver a lot of power with just 3 pairs, only 3 pairs. And the total amount of distortion, as you can see here, is pretty low. Let me show you. This is 8 ohms low right now. I'm going to change this for 4 ohms low, so you will see that I do have good designs that I can use for other purpose. Right now I'm going to show you the Honey Badger that Mr. Ostripper designed a long time ago. So I'm going to activate the simulation. As you can see, we have with only 3 pairs, 386 watts to 4 ohms low, with just amplitude of 700 millivolts, 1 kilohertz. As you can see, the total harmonic distortion is so low, it's 0.005%, and we have 386 watts. So that's plenty of power for this design, for this amplifier. I'm glad that I spent some time to create a clone for myself, of course. So this is the clone of that design. Sadly, I do not have a larger heatsink so I can test it out. I really do not want to risk the outputs by using just a piece of aluminum that I have to test it out, and it's really sad that I cannot test it because first, I'm kind of broke, to be honest. I'm kind of broke and I cannot continue doing this, and it's difficult for me that I spend a lot of money on this design. I mean, this is not my design, it's just a clone. It's a clone for my personal use, because the actual PCBs, they sell these PCBs on DIY.com, and I'm going to show you that it's actually reality. They do have those PCBs. I'm not announcing them to, I'm not lambiéndole culo a ellos like we say in Spanish. I'm just saying that it is available on the DIY store. So what I did, I just clone that PCB for my personal. I think I like to challenge myself, so that's why I did it to make it for myself. As you can see, it's the same design as you can see here on the image. I also have this image on 3D that I made for the Honey Badger. So I have a Honey Badger on 3D. Let me see, I think it's here. So this is the Honey Badger, the 3D view of the Honey Badger. But you can actually purchase this PCB in DIY.com. I'm not sure if they have those available. Let me see. Honey Badger. This is the schematic, as you can see. Got the schematic and everything. Version 2.4. So you can actually purchase this PCB. All right, let me see. But this is a well designed PCB. This is a really nice, well designed PCB. As you can see, this is the schematic, and I was able to successfully simulate it on the Multisim 14. It was pretty good. I mean, I just have, let me see, It's working with just 60 volts. You will get about 300 and something, 380 something watts. That's pretty good. I mean, yeah, that's plenty of power. Okay, now let's go back to this design, the high fidelity audio amplifier. So what I'm gonna do, I'm just gonna delete this stuff right here, so it's not needed. Cause oh, sorry about that. I'm just gonna work with just 3 pairs, so I had to make some modifications to this PCB. It will help because it's not gonna be that expensive. You having a when you make the PCB smaller, it's going to cost less money. The larger the PCB is gonna cost more money because they charge. I think they just charge more for the area, how much area the PCB is taking. So that's why it's a bit more expensive. Let me hide the C2 and C1 so I can delete all this. It's not needed. All right. So continue talking about this design. I don't think it's needed for me to change this. What I'm gonna do, I had to add some circuits here. The driver transistor, they are not illustrated here, so I had to add those here. So let me see. No, not this one here. This is the honey badger. So right now I have to add this circuit, the Q22. This is the driver transistor, and R31, C15, and the other transistor Q23. Those are the driver. We call it in Spanish impulsores, transistores impulsores. You know, they just push current, something like that. I don't know. I really don't want to complicate you guys. So I'm going to continue delete all these files that I don't need because I only want to use just 3 pairs. I think 3 pairs is just enough. I mean, you don't need to go crazy with so many pairs of power transistors. So what I'm gonna do is just delete all these files that I don't need. So I will delete. Oh, sorry about that. It's okay. Split the group so I can delete all these that I don't need. Let me see. There you go. Perfect. So I'm going to delete this only to leave. Let me see. Split the group. All right. So I'm gonna hide the C2 so I can delete all these. So like I was saying, that you don't need that many transistors to get a lot of power. I mean, I'd be happy with just maybe 150 watts. You know, 150 watts is just enough. I mean, you're not gonna be listening to music with the volume so high that you're gonna burst your eardrums. That does not make no sense at all. So right now I'm going to find those driver transistors. I think I do have those here on my macro directory or library. That's the best way to say it. So I can install those there. I have the idea. Probably I will. Maybe I don't know. Let me put it here. This is the bias transistor. This is a really important component. So I will look for driver transistors. Okay, there you go. We have one here. I can use this one here. It's good. There is a little problem. I think it's fine. I think I can just modify this because it's just gonna feed. I'm just gonna feed the collector of this. Okay, I can edit that. No problem. I can do that. So let me hide the full screen so I can work with this. All right, a lot better. Okay. There you go. So I'm just gonna feed the collector of this power transistor, audio transistor. So I'm gonna do the same thing here. I think I'll be able to do that. So I want to move this over here. I like to make sure it's at 90 degree. Nope, not that one. Let me see. I think I'll be able to do that. All right, cool. So now it's feeding those power transistors. So now we have the driver transistor. This is the PNP. Okay, let me do this. I'm going to put it here to align the driver transistor because those they need to be attached to the main heatsink. So right now I had to make a how you call that? I think I can leave it like that. Yeah, I think so. Yep, I think I can leave it like that. Okay, I have an idea. Hold on, guys. I have an idea. Gonna place this over here. Gonna clone this transistor. That's a good thing about cloning the components, so you don't have to look for the component again and again. Okay, so I'm gonna place it over here. Use the grid of the same seal screen so I can move both components at the same time so they will align nicely. Oh yeah, I had to give it some space, so those power transistors, they need more space because the temperature, they need space. So I think I can do that. Yes, I can do that. So I will do that right now. So it's no problem. I'm gonna move this over here, and then I have to figure out how I'm going to add that. Yeah, I can place a nice large resistor for the. Yeah, it's okay. It's okay. All right, I'm going to move this. So what I'm gonna do, seal screen. I'm going to select these components. Nice, perfect. Build group. I will do the same thing with these other components. Build group. Here, build group. I have an idea. All right, let me see. Let me see. I have an idea. I think I can do that. Q15, Q. Okay, so all right. Let me do this. It might be that might sound crazy, but all right. Let me do this. I'm going to move this over. It's okay. Don't worry about that, because I'm going to delete those seal screens that I have here, so I can just place those later. That's okay. I'm gonna move it up here. Okay, you are designing audio amplifiers. There is a tool that you can use so you can duplicate the components as many times as you want. I mean, but don't go crazy. Don't go with 24 pairs. That's impossible. I mean, you can do it. I don't know. I think the largest PCB the companies can make, I think it's more than 500 millimeters. I think so. So right now what I'm gonna do is I'm going to duplicate this using the tool, and I'm not gonna delete it right now. There is a tool. You right click, and you will go to Tile, Arrange Circular, and then I'm going to use only 3 pairs, and I will give them some space so they will dissipate all that heat, because they don't need to be that close to each other, because that will create problems. So right now 30, I think 30 is fine. Let me see, 30. I think it looks nice. I think like that, because you need to give it some space so they can breathe. They can breathe, you know. So right now okay, I'm gonna put this over here. Yeah, I gotta delete all these files. That's I'm gonna delete it right now. It's okay. Okay, so it's fine right there. Gonna delete this one here. I don't need it, so I will use it later. So I want to make a group of these so I can place it later. So I will give you a trick on how to place all those components. I mean the part numbers faster, a lot faster. So I think it should be fine like that. It will give a lot of space. So right now I'm going to move this over the rail, the positive rail for the. I think it's fine right there. I think it's way too close. Let me see. No, it's okay. I think that rail maybe, I don't think it's needed to be that thick, because when I create that rail, it was intended for a high current we go through. Right now on the right of your screen, where you see the detail properties right here, one track, I select that track, and you will read the distance is 95.250 millimeters in length, 2 nodes, and maximum current is 29.3 amps. But if you're using 2 ounces of copper, 2 ounces of copper, I think it's 70 micromillimeters. I think it's 70 micromillimeters. It will withstand. I think that's it, right. it will withstand 41.5 amps, so that's a lot of current. So I think having these trays at 9.50 millimeters in thickness, it should be just fine. So it's cool right now. So right now I'm going to do the same thing here. The bottom here, I'm just gonna delete some components that I don't need, because I'm just gonna duplicate this again. You can see it's a lot faster this way. So I'm just gonna save one of these. All right, it's cool. So I'm going to duplicate it. This group of components. We have the transistor, we have the emitter resistor, and the base resistor, base stopper. I think they call it the base stopper. So what I'm gonna do right now is going to move this over to the left, align this with the other power transistor. I think they are really nice on alignment. Let me see. We got 90 degrees. Yes, we do have 90 degrees. So right now I'm going to duplicate it. I'm going to duplicate this again with a distance of 30 millimeters in distance between them, so we have plenty of space, so they don't heat up that much. So they don't need to be that close to each other, so you gotta give it some room for them. All right, there you go. And then we are going to smell like perfume. That's weird. I think that's one of my knees. My knees. All right, so I'm going to continue here, editing, making some additions to this. So it's fine right there. Cool. So we have that ready to go, and I'm a little worried about this. I think I can make this a little larger, but it's okay. So now that we have all these spread out, all these components, so now I need to complete the circuit, the driver, transistors drivers. Okay, so let's see the part number. Going back to the simulation and look for it. So right now that's Q22. Q22 is MJE 15032G. There you go. So right now I will suggest this to you guys, so you are practicing using the spring layout. What the hell is that? I will suggest to you to use this method. This is the correct way to assign the component value. What the hell is that shit? Sound like someone is shooting. What the hell is that? Yeah, man, we in Puerto Rico, man. You know, things happen. Luckily I'm surrounded by concrete. Holy shit. All right, so this is let's go back to the design. Q22 right now, so it's Q22. Make it visible. There you go. And I assign the part number. Make this a little smaller. That's nice. And you will see that is now identified. So really important here is to move this how you call it, this component that now is identified. You can see when I move the component name, it will be show you that this is the component. You can see there is a little black line that said no, this is me. So that's the good thing about this assignment of components. So right now I'm gonna put it right here. I think it's way too big. Let me see if I can change this. Let me see the size. I think it's too big. Normal volts is 1 millimeter. Okay, let me see. I'm just gonna remove the G so we know. Anyway, there you go. So we're just gonna place it there. Later, okay. Let me explain you. You will begin to place the components, but as you go, you have to think. Okay, it's best if I move this component to the side. Maybe I need to rotate it. Maybe I need to eliminate some jumpers that I don't need. So you gotta think about many things. So it takes time because right now, okay, this PCB I did it really quickly. I was really surprised that I made it really fast, because in the past it used to take a long time for me to do it. So right now I think I figured out how to do it a little more faster than before. So right now I'm going to continue here. I think I gotta move this a little closer to the, I don't think it's needed, but let's see. Oh, I have to edit this, so I gotta move this over here. I gotta edit this and place it over here. Okay, let me see. Oh, there you go, it's green. When it's green, it's done, it's good to go. There is one circuit that I'm not sure if I'm gonna add this circuit. I think this like a limiting or protecting circuit. All this circuit right here, you can see. Oh, what the hell happened here? Don't worry about it. We got the under, so don't worry about it. So we have this circuit here. I'm not sure if I'm gonna add that circuit because on the driver board is just Q22. I will add this filter capacitor for the base and collector to avoid oscillations, stuff like that. R31 is in parallel with C15, and we have the other two more components to add just to complete the circuit. And also this is Q23 and C19. So we all have also the base stoppers that on the what the hell I'm doing. Let me see. On the original, the fish again. What the fuck? Get the fuck out of here, fish. On the original schematic, you don't see those the hell base stoppers. I got a lot of stuff on my computer. God damn. I need to purchase a new hard drive so I can save all that data. So I don't want to lose all that. As you can see on these, you don't see any base stoppers because this is an older circuit, and I think the designer he decided not to use base stoppers. So I will use the base stoppers. I mean the resistor is just 2.2 ohm resistor, so you can use those. So 2.2 ohm resistors, and this is the circuit that I was talking about. Is Q20. We have diode DA, R25, R26, R27, R28, R29, Q21, D9, and R30. So those are the extra transistor that it needs. I'm not sure, but I think this is 15K. 15K. I do not see that clearly here. I think it's 15K, but it looks like 16. So that's the problem about this circuit. I don't see clearly. You can see I don't know if this is 16 or 15K. So it's a bit difficult, you know. Let me see. I think it's 15K. Let me change this to 15K. So I change it to 15K. Trying to do some investigation here. I think it's 15K, not 16K. So I will change this to 15K. Alright, let's continue here. On this design, the fish. Oh man, this fish look funny. I don't know, I was doing some crazy stuff. Alright, let's see. I'll go back to the design. So right now we have the driver, and this is a negative feedback, but it's recommended to get the negative feedback as close to the coil as possible to feed the resistor. This one here, the R15 is 10K. On the simulation I changed it to a larger number, so just to get a little bit more feedback, to get more power, but I think I will leave it at 10K. Let me see, at 10K I think it's not gonna let me see, I want to change it to the original value to see what's gonna happen. God damn it, what happened here? There you go. Alright, so now we got 10K. So okay, the last results with 980 millivolts, we had 217 watts. If you change that negative, I call it the negative feedback resistor. That's for one reason, negative feedback resistor. So right now I'm going to activate the simulation, and you will see that it will decrease the output power to 88 watts. So well, yeah, I know. So it might be, for some reason, it's 10K. So I'm not sure if I'm going to change to 16K just to get a little bit more power, because right now if you change that negative feedback resistor to 16K, you will get a little bit more power, of course. So right now I'm going to change this, and you will see that it will give you about 200 watts, let's say 200 watts, and the total amount of distortion is 0.021. I think it's acceptable. I think so. All right, let's continue with the output PCB power board. So we have on the circuit, let's check for those components. Something that brought up there upstairs. All right, let's see Q22. Okay, we got Q22. We need R31. Okay, let's get our R31. So what I'm gonna do is just to get a larger resistor, because that one can be a 1 watt or 2 watts. It's okay. You don't need to be. Let's see if I can have one that is 1 watt probably, or 2 watts. Okay, this is 3 watts. I think I can make a trick here. I can do some modifications here, of course. Yeah, I think so. I can do some modifications. All right, let's see. I'm gonna make this different. This is this resistor is 150 ohms resistor. Okay, 150 ohms. I gotta modify this to 150 ohms. I don't know for how long I'll be making this video. Oh Jesus Christ. Anyway, I will continue. What time is it? 12:32 here in Puerto Rico. Yeah, it's okay. Doesn't bother me. So let's make the leads a little longer. Yeah, I think I will do that. I'll make the leads a little longer so I can. Okay, hold on. Okay. I'm just gonna count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, cool. I will do the same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So right now I'm going to make this longer. The leads. I need to change the size of this pad to, let's go with 3.5. Sorry about that. 1 millimeter thickness of wire. I will do the same with the other. Okay, I think I gotta edit this. So for me, for not to waste time, so I just gonna clone this part. So I just gonna move it over, and I think I got an idea. So I can delete it. Put it over here, so I can just take this and delete it. There you go. I gotta change the size of this pad for the other one. 3.5, and this one will be 1 millimeter thickness of the. So now I'm going to select all these macro and create a new macro build group, so I can move it around. I gotta make this thicker. Let's go with 0.50, so you will see it better. There you go. And now I have to do some modification to these traces. So I'm gonna place it over here. The negative feedback fasten connector, I gotta move it over. I'll place it over here. It's good to have it. This is the ground. Okay, this is the ground connection. So I gotta do some changes here. Alright. Okay, I think I can do that. Gotta make some modifications here. Alright. Ground connection. Okay, there you go. Oh, nice. There you go. Perfect. So okay, now I will edit this. Mailman. Oh, something. You got something? Oh man, sorry about that, guys. I had to go check the mailman. The mailman was here delivering stuff to our house. Cool, huh? And now I'm going to edit. So this is the driver transistor. I think there's too much. It's like a way too much space, too much wasted space. But anyway, this PCB is not, it's not that thick. I mean, it's not, you know, it's not that wide. It's 100 millimeters. It's not that big. All right. So let's see if I gonna. So this trace need to be connected here. So I will just edit this. All right. Let me see. Because the emitter of this transistor, it needs to be placed over here, as you can see here. Yeah, it is kind of difficult. It is. Think about it. You gotta just think about it, how difficult is this thing to do. All right. I don't know, man. This does not look that good at all. I don't know. Maybe it's just me. It does not look good at all. I don't know. Let me see. I'm just like that. Let me see. So the collector, you need the voltage from the supply. So I need to supply voltage to this transistor. There you go. It's a good thing that I can just edit this, make it look nice. There you go. So when I'm supplying voltage for that transistor Q22, the collector, as you can see here, is feeding that. Okay, let me change the colors of this net so you guys can see the difference. Let's change it to yellow, or let's say red. No, it's red already, so let's go with this blue, something like that. Blue, no, something light so you could see it. There you go. So it's feeding those components, as you can see here on the blue line represent the voltage, the positive voltage of the circuit. So it's feeding this transistor right now. So now we need the base. The base, I think it will be just, hey, how simple is this? Yeah, it's crazy. All right, cool. So right now I'm going to connect this over here, and it's completed to complete the circuit. There you go. I like that. There you go. So now we need the emitter of this. This connection here, ND. That's crazy. ND. So the negative rail for this transistor, it needs to be connected. All right. Let's go here and connect it. I don't know why it's doing this. I don't like this. I always remove it. The extra node. The node. I don't know how to pronounce it, guys. This is the word. That blue thing that you see on the screen is node. This is the name of that thing. I don't know how to pronounce it. Okay, this is the name, node. You can see, if I right click on the screen, you will say remove node, node or node. I don't know how to pronounce it. Let me know, guys, on your comment down below how to pronounce this word. I'm not sure how to pronounce it, because node or node, I don't know. This is the word. So let me know in the comment down below what's the name of that, how to pronounce that word, because English is my second language. It's kind of difficult for me. All right, we had that connection, but we got a little problem here. As you can see, we got the base, and we need a filter cap it's in parallel with the R31. So this resistor is actually R31. I forgot to identify this component, but this one is R31 visible. And yes, I don't have to place the value because I already did it. So this is R31. Let's place it over here close to the pad. There you go. R31 right here. All right. So we need the filter cap, and we need to connect. It looks like I got plenty of space to add this protection circuit. You only have just a few components. It's not many. As you can see, it has basically 5 components. I think we got one a diode DA, Q20, R25, R27, and R26. It's just 5 components, so I think I'll be able to add those with no problem here. I think no problem. So this is the positive rail first, 2N5550. See, I'm gonna use this. Yeah, I'm gonna do that. All right, let me see. Now we need to add the capacitor. This 1 microfarad. Was 1 microfarad? Let me see. Hold on. Let me see. Yeah, it is 1 microfarad. Ah, I don't think it's polarized. No, it's not polarized. Oh, cool. Hold on, let me see. Give me. Oh, nice. It's not polarized, so I can use those film capacitor. I think I'll be able to use those film capacitor. So what I'm gonna do now is create one film. Let me edit this. Let me see. There you go. That look nice. There you go. So again, let me continue here. I think I will leave this circuit, this rail circuit. I will leave it. I will leave it there. I think it's gonna be awesome to have that there. Let me see. I need to make the film a filter. I will use a. Let me see, 1 microfarad. Let's see. Let me go to DG key. DG key. Let's see. Okay. Film. We need a capacitor. Film. We got film capacitor. We need 1 microfarad. 1 microfarad. There you go. They do have it. All right. In stock. Apply filters. And I will choose a larger one. So with a lead space of probably 15. Maybe. Let me see. Lead spacing right here. We have 10 millimeters. We have 15 millimeters. I think it's better if I choose filter. Sorry about that. 15 millimeters. All right, we have it here. We got the winner. Let me see. We have those. I don't like those. Let me see. It's okay. Epcos. No, okay. 100 volts. This is fine. $1. God damn, $1. That's too expensive. Jesus Christ. It's way too expensive. Description, factor. Minimum amount. This is 80 cents. All right, let me choose this one here. It's okay. I just need to read the how you say the size. Okay, 18 millimeters by 8.5 millimeters. Okay, lead space is 50 millimeters. So 18 by 8.5. Sorry about that. 8.5. 8.5. All right, let's go. 50 millimeters. Footprint wizard. I will create that right now. And 50 millimeters film capacitor. All right, that's a pretty large capacitor. God damn, Jesus Christ. There you go, 50 millimeters, 1 millimeter of hole, and 3. There you go. All right, now this is the film, and it's 18. The size of 18 millimeters in length. This is the outer. The silkscreen. I will create a silkscreen for this device. this capacitor. So right now we have 19 feet. And let's go with 20. Yeah, let's round that out to 20. I don't think it's needed to be perfect. 20 millimeters is fine. And it says 8.5, so we just go with 10 millimeters. It's fine, it's fine, it's okay. Let's go with 10. Alright, 10 millimeters. I think it's too thick. Alright, 10 millimeters. Well, clone this and then clone this to make the capacitor. Damn, Jesus Christ, that's a large capacitor. Jesus Christ. It is large. Damn, Jesus. That's too thick. I go to 30. And now I gotta find to center out this to make it center. I gotta see if we have alignment. Okay, we got alignment here, good. We got alignment here, nice. And I just gotta make sure this is aligned. Let me see. Yes, it is. It is. So right now, I'm going to take this filter, put it together, build the group, so it's ready to rotate it, so I can place it in parallel with this resistor right here. So I just gotta make the connections. I think I might be able to add a few more options on the capacitor side. So I think I can add a, what you call it, the 10 millimeter pitch distance, because we have more choices to get more choices. So let's go with 10 millimeters just in case, and then I just place it right here, so I will have the extra option. There you go. Let me see. There you go. Oh yeah, because I make the pads really large, that's why. Let me see. I gotta make this pads smaller just so I can. Oh yeah, nice. There you go. That's what I mean. Nice. So I will have two options. So now I can connect this film capacitor. Alright guys, I think I'm going to stop the video right now. I think you guys you're gonna sit for so long watching these videos, so I'm gonna stop the video. I will continue later. I will upload more videos about this design little bit by little bit. So yeah, alright guys, have a good day. It's take a long time. Alright guys, have a good day.